Welcome to this ThinkSmallCell webinar, The Enterprise Unlocked. And today we're going to be talking about enabling the rapid adoption of enterprise small cells. I'm joined by Alan McNab, the global small cell go-to-market champion at Cisco, and Benoit Fleury, Vice President of Products and Innovation at iBwave. The structure of our event today will be an initial introduction from myself, looking at how building owners, IT managers, IT departments can potentially deploy their own small cell networks in a similar way to the enterprise Wi-Fi schemes that we've seen put in place already. And then I'll hand over to Alan, who will talk about his experience from the field, where many enterprise small cell deployments are becoming a reality. Part of that deployment, of course, requires RF and network planning, and that's something that Benoit will discuss in his section. And then we'll take as many questions as we have time for in the Q&A session. So I'd encourage viewers to submit questions at any point during the webinar through the control panel on your right-hand side. The slides that we've used, a recording of this webinar, and the accompanying white paper will be sent by email to all attendees within 24 hours of this event. Now, the problem really is that in-building cellular service has been arguably poor and worsening for some time. And there's a number of reasons for that. The construction materials being used for buildings typically aren't friendly to RF signals getting through from outside. Whilst they're very thermally efficient, the signal levels and the signal quality indoors can be significantly reduced. There's also increasing traffic demand as we carry more smartphones and consume more data over wireless. Now the issue is where the signal quality is low and that signal to noise ratio is poor, you may well have a strong signal, but the data rate that supports may not be very good. The fastest data rates on 3G and 4G require these high signal to noise ratios in order to use the highest modulation schemes. And if that's not available, then traffic throughput reduces. And we also see the effects of cell breathing, where within a 3G cell, the range and the footprint of cells can be reduced in times of congestion and heavy traffic. And a third factor is less to do with the technical capabilities of the system and more to do with the increasing reliance on wireless devices. More emails are now opened on our smartphones and wireless devices than on our desktops. And we expect as part of our normal business life to be permanently connected, which isn't always the case. An example of that was at a conference where we were talking about 5G, whilst at the same time we couldn't access, never mind 4G, there's no 3G service within the building. That's not unusual, and this is perfectly captured by Murray Rumney of Agilent in this slide. So what can building owners do? Well, dependent on what their network operator might offer, it could be a high cost, tailored, specially designed solution that might cost hundreds of thousands of dollars. And indeed, if you have a large sports stadium or shopping mall, perhaps that's a sensible approach. Alternatively, there may be a one-off, simple femtocell solution that could be installed for a specific user or office. And we are seeing a growing range of in-building cellular solutions come on the market to satisfy all types of sizes of buildings and use cases, but we're not necessarily seeing those heavily promoted by the network operator. So instead, we've seen many enterprise Wi-Fi networks be deployed. These very high quality Wi-Fi service, significant investment in the infrastructure in order to allow businesses to cater for their own staff and visitors. And the question is whether this concept could be extended for them to self-install cellular systems, cellular small cell solutions that can then be connected to one or more network operators. And perhaps the first question is, who would install that? Is it the network operator? Is it the property owner, some of his staff? Or is it a third-party system integrator? And one way to look at this is to divide the problem into three. You would need some capability to plan both the RF and the networking of the equipment to be installed. And that's something that Benoit will talk about later in this webinar. You'd then need that equipment to be physically installed, as you can see in the photo. And that's something that can typically be done by the same staff that would deploy the Wi-Fi hotspots today, or the burglar alarms, or the CCTV. It's not a very specialist skill, and it's something where familiarity and access to the building is perhaps more important. And then thirdly, the system needs to be commissioned. It needs to be configured. It needs to have the frequencies that it's going to use and the power levels calculated and assigned. And that's something that I would say the network operator needs to oversee or implement directly. Now, there are a number of software tools now, self-optimizing network features, which can considerably simplify that process. And of course, it's not a one-off deployment. You would expect periodically to have to come back, revisit, replan based on actual traffic patterns, which would typically change over time and either move or augment with additional access points and small cells as required, which again would require some reconfiguration and optimization. And that commissioning and that optimization would also require an integration with the external macro cell network. A couple of choices that a building owner has to consider. Firstly, is to whether a single network operator service would be adequate, and they could lock themselves into a single operator who may be more prepared to subsidize or cost share the system versus a multi-operator or so-called neutral host solution, which supports multiple network operators. Now, there are a number of technical approaches to implementing multi-operator systems. You could either simply deploy additional small cells. Perhaps every alternate one might be for operator A or B. You can buy products which support multiple radios, and you could allocate one for operator A or B. You can make it a commercial arrangement through national roaming, or you can install a different technology such as a DAS system, distributed antenna system, which allows multiple operator base stations to be connected to it. And the second question that has to be asked is whether to go for 3G or LTE or both. Arguably, the most popular common technology, especially for voice today, is 3G. But over the next few years, we can expect LTE, especially as voice over LTE is deployed, to become more and more common. So in the short term, either 3G or a product that can do both would be perhaps a good investment, but at some point, LTE only would be equally, if not more valid. And last but not least, it's the question of who pays. And that's not just for the initial deployment, but also the ongoing costs. And related to that, who's accountable for the good quality and performance? Something that has a plus side to it. If the service is really great, then perhaps the network operator would benefit from that just as much as the building owner. The good news is that there are a whole new range of products that dramatically reduce the cost, not just the physical equipment cost of the box, but the processes, the skills, the integration effort that's required to configure and deploy these systems. So there's a lot of promise, a lot of demand from building owners and businesses who would like to enable and equip their properties with good cellular service. And at the moment, it's arguably underrepresented. Something like 80% of cellular data is consumed indoors today, but only 12% of the infrastructure spend is on equipment which is installed in building. Now, I've just touched on a few points here, but these are explained in more depth in our white paper, which you can download from the link shown, and we'll send that link out with the follow-up email to you tomorrow. That being said, I'd now like to ask the audience a question, and that is whether they believe that the in-building cellular service that they perceive themselves match market demand today. Okay, and as you can see from the results, almost half of you think it's somewhat below market needs. A significant number, almost a third, really feel it's significantly below where it needs to be. And there are a few people who are really very happy. So I can't tell which country or which network they're with, but it's nice to know that we've got some parts of the world which are well above average. So at this point, I'd like to hand over to our next speaker, Alan McNab.
Well, thanks, David, for the opportunity. Very much appreciate it. And I'm about to talk about what at Cisco we think is a unique way to move the small cell market forward and really accelerate adoption in what we see as very much an underserved part of the market, especially within the enterprise, large and small businesses who are desperate for very cost-effective in-building solutions. We think some of the larger challenges around regulatory constraints and really the cost of small cell devices, it's quite a competitive marketplace. The prices are I think, quite acceptable to enterprise customers. We also think some of the issues in terms of site acquisition, building owners, are very much open now, considering the size and real estate necessary to deploy small cell. So we think some of these initial hurdles have been well solved for the marketplace, but the challenge in terms of wide adoption is really about the cost of deployment. How can we do this in a way that isn't encumbered by an enormous amount of labor or enormous amount of costs associated with that? And I think what we're looking to is really leverage Cisco's partner organization who are out there today deploying Wi-Fi at scale, and with that kind of tap into that expertise in the field, who are working day in, day out, enabling enterprise mobility solutions to deliver licensed radio solutions. And then also, I think it's not just simply about in-building coverage and capacity, but it's also about figuring out additional ways for people to add value to the marketplace. And so that's a little bit about what I'm going to talk about today. So moving on to the next slide, please, David. So there's a huge transition going on and has been happening in the enterprise for some time. We think especially within the last year, as 802.11ac has become available, we're seeing an enormous amount of investment in sort of enterprise-wide high-density Wi-Fi. And this investment offers enterprise customers and also mobile network operators an opportunity to kind of leverage that investment, that transition from 802.11ag or .n to AC, and tap into that labor that's going up into the ceilings to replace old Wi-Fi gear with new, and tap into that investment, so at the same time we can deploy small cell. So we see this trend, right, in terms of enterprise customers, large and small, foregoing desktop switching and really making an investment with this wide coverage. And that's really, I think, the market opportunity that's unique at the moment to really help lower the cost of small cell. And that's why I think we're in a position to really take advantage of this in-building Wi-Fi to bring small cell to bear for the enterprise. And when I say enterprise, I mean large and small businesses, as well as large enterprise customers with big buildings and lots of branch offices. So moving on to the next slide. So in terms of that network, Cisco has been very very partner friendly for a very long time. And specific to the Wi-Fi market, we've been delivering that technology for over 10 years. We've certified 15,000 partners, and these are the people that we're working with today to really help understand, what are the customer challenges around in-building licensed and obviously unlicensed solutions. What can we do in terms of capitalizing on their expertise so that we can bring a solution to bear to their customers. The marketplace in Wi-Fi continues to grow very rapidly, and it's quite astonishing in terms of the scale. It's about 10,000 enterprise class access points that are deployed every day. So these aren't just residential or small office, which are different markets. This is enterprise class, highly secure, that offers a lot of management capabilities, a lot of quality of service, and a lot of security for enterprises. And this has all been driven by bring your own device for both licensed and unlicensed end clients. And then also we've obviously got partners that can do high volume, but as well as partners that are very specialized in specific markets, healthcare, hospitality, financial services, that again are looking to help enable unique applications within their vertical market and the customers that they serve. Moving on to the next slide. So in terms of, I guess, really where our phones are ringing off the hook, as you mentioned, David, at the beginning, it's pretty straightforward. Just skipping on, it's a bit of a build here. The basic premise is that our customers who have, basically endorsed the policy of bring your own device, fundamental requirement is around voice, 3G voice in building. We talk to, for instance, banks who have got thousands of remote offices. They'll have employees that are salespeople that are out on the road. They'll call into a local branch office. They'll have enabled call forwarding from the IPPBX to their mobile phone, and they'll go into a local branch office that won't have great coverage, and because of that, they'll miss a customer call, and it just doesn't look good. So to that extent, they desperately need this ability to be able to enable 3G in building at remote branch offices, and obviously that's where they have Wi-Fi deployed. And we're talking to hospitals that have dark spots just due to the construction of their buildings, and they've got to put a lot of protective material in there that prohibits the macro tower from penetrating the building. They need hotspots or 3G in building to basically, obviously, find consultants or doctors or even patients that are in their beds who want to reach family and friends. So for us, the applications, the requirements are very, very loud and clear from our enterprise customers. I even spoke to a car company the week before last who rent cars by the hour, and they basically locate a lot of their cars in building, and while they actually have Wi-Fi coming from the car to collect a lot of statistics, that Wi-Fi battery the Wi-Fi demand can actually drain that battery. So they'd rather go with 3G or LTE, which is more efficient in terms of battery, in terms of using the battery to communicate the car's statistics. Now, it's not just simply about that. We see an awful lot of other value added coming in terms of facilitating location services, presence, emergency services, other capabilities in terms of being location aware, and some level of automation in terms of guest services and where people may be in terms of trying to take available of an open conference room, things like that, which we see kind of integrating with unified communication applications and other enterprise class applications. In terms of the way that we look at the market, we're really capitalizing on our experience with residential, and from there really extending into a part of the marketplace that we think is underserved. This is, remote offices, branch offices, areas where DAS really isn't cost justifiable from an expense perspective, and that's a marketplace that is really well served by our enterprise channel partners. They're in and out of those offices every day, either deploying and expanding the Wi-Fi network, and we certainly think that the capabilities required to deploy small cell in those locations, will be very straightforward. And so it's really about building on that residential experience that we have to move up the market, if you will, into these more sophisticated offices. All right. We think that large venues and large offices are well served by DAS. and that's not a place that we're hearing from customers. We're really focusing on this part of the marketplace that we think is underserved. So moving on to the next slide. So really, in conclusion, when we think about unlocking the market opportunity in the enterprise, we think about the customers, who we want to serve really who are underserved today, right? We want to basically take advantage of a lot of the resources that are going into deployments today, so we can tap into that and really lower the costs. And so we want to partner with folks like iBwave, who can make and simplify in-building solutions and combine the licensed and unlicensed assessment, design, and implementation. We're investing today in training programs. These are early adopter training programs that basically can help our partners come up the learning curve, but then ultimately integrate well with the operator, who ultimately has the word on when the service will be deployed. We obviously also need to deploy support processes that if and when there are breakdowns, that our partner organization will be well coordinated with the service provider so that we can continue to deliver a great in-building service. And then lastly, we really want a technology that does simplify it, doesn't complicate it. And so we've got technologies that basically integrate both local SON and macro SON, right, into a complete solution that really kind of harmonizes both networks. So that's really all I have to say, and I look forward to the Q&A section.
Thanks very much, Alan. And I'd remind our audience that if you have any questions for Alan, please do submit them at any time during the webinar using the control panel on your right. What we're now going to do is ask you a question, and that really relates to whether you believe that building owners and or third-party system integrators can competently install these in-building cellular solutions. So let's see what you say. I think most people have voted now. I'll close the poll. And as you can see, it's actually very equally split. About a third of people think it's perfectly reasonable, and about a third of the people think it's highly unlikely. Alan, do you have any comment on these results?
I do. I mean, we've been working on large and small deployments, I think, and it is about training partners very well. This is a new domain. I think what is very different really is about local coordination of the SON network with the macro network. There are very stringent regulatory requirements on carriers in terms of quality of service and their KPIs. So I think it is something that has to be invested in well. I think, Wi-Fi has been around for a long time. A lot of the technology in and of itself has simplified. So I think small cell has got to go down that curve as well in terms of simplification, management, etc. So I would probably prefer to be in the middle of that. I think it is possible, but we need to tread cautiously.
Thanks very much, Alan. So without further ado, I'd like to pass the baton over to Benoit from iBwave, who'll be talking about the deployment dynamics and planning tools.
Okay, David, thank you. So let's start by understanding the context of deploying indoor small cells versus traditional DAS networks. So indoor DAS systems, although they are becoming smarter and increasingly more dynamic, are inherently complex and therefore tend to be much more engineering driven. Now, they'll typically take weeks to months to plan, and they'll require a certain level of RF expertise for proper designs. Now, having said that, they are quite well-established processes. In contrast, small cells are targeted to smaller or simpler venues with greater volumes, as was alluded to by Alan just a few minutes ago. So, hence, for those to be economical to deploy, the planning phase needs to be significantly simplified, needs to be shorter, and a lot cheaper. So they really need to be field-driven. Now, however, it's important that engineering should remain involved, but without necessarily being a bottleneck. All right, so what can we do to really simplify indoor small cell designs? Well, the first thing is to have a tool to guide field personnel in all the steps that are needed to survey the site, to plan the network, and to design it. Now, please bear with me as I would like to share with you the key steps that are required so that you can have an appreciation of the level of knowledge which is required. Now, the idea is to achieve all of this in a single visit while on site. We've recently introduced a product called iBwave Mobile that provides the ability to create small cell designs directly in the field in a manner which is extremely simple, surprisingly quick, and much less costly. And this is the result of input we've had from a large number of operators and integrators, and also resulting from more recent trials from different regions of the world. So the three main steps are as follows. The first is to obtain a floor plan, either from downloading it from somewhere or just taking a picture of the layout that you would typically see on an emergency exit plan. Then that layout needs to be scaled. We do that with a ruler function, which is integrated here with the tool. And then certain site level parameters would be set at that point. So that's our first step. The second step is to access a parts database and select the desired small cell. Now, all the specs of the small cell are modeled and integrated, such as the band, the type of antenna, the technology which is used, and the output power, and so on. So place these. The next thing is to place those on the floor layout with a simple tap of the finger and activate the prediction mechanism in order to rapidly visualize the coverage or the data throughput, as the case may be. And then either add, delete, or move the small cells around to get the desired result. Note here that the prediction map that is generated will also take into account the existing RF environment so that the resulting propagation map will be sufficiently precise. The third step is to add the network equipment that is associated with this particular indoor small cell design, such as routers and switches, but also cabling routes and various annotations to document various aspects of the site for later installation purposes. So this can be in the form of text, pictures, videos, or audio recordings. All right, so once we have a design completed, the next step is to store it somewhere centrally for later retrieval. Now, why is this important? Well, over time, there will always be a need to either add capacity, upgrade technology, or make some other changes. And it's important that the design is well documented as a baseline to be used down the road to know precisely what changes are needed and where everything has been installed in the first place. Now, for more complex venues, it may be necessary to get some form of engineering approval. As such, the design can later be retrieved from an RF engineer sitting somewhere at an office somewhere else, using a more powerful desktop tool, such as iBwave Design, and approve the design or perhaps make some improvements to it. Once that is done, these changes would be stored back into the cloud to be later accessible by the mobile device. And what's key here is that it's not about a single product or an app that to simplify the overall indoor small cell design process. Really, a complete solution is needed, and often this will lead to different products to be used perhaps by different people from different departments. But the important thing is that all of those are well synchronized together. So now, having said all this, what expertise is really required to use iBwave Mobile Planner? Well, we've optimized the product such that it can be used by field personnel that have just very basic IT knowledge, such as the field techs, IT specialists, or contractors, to name a few. But in order to ensure that we have consistent levels of quality in performing the site survey and the small cell design, well, there's a one-way training program which is provided, and that is primarily a hands-on training that includes a lot of exercises and a hands-on workshop as well. In due time, we will incorporate an exam to make it into a certification. That's in line with the certification program that we already have in place with iBwave. And that will be important because a large number of integrators and contractors will be involved in that process. So clearly, inconsistent levels of design quality will definitely result if the proper steps aren't consistently followed. So although the design of an indoor small cell network for simpler venues can certainly be handled by field personnel that are not RF experts, some basic training will still go a long way despite how simple the design tool might be. So now let's look at a specific example, which in fact was carried on just a few weeks ago. And the venue in question is a 7th floor warehouse located in downtown LA. So in a single site visit, a survey was performed along with the small cell design, which included the ideal placement of the small cells. It included the various network equipment that's required to hook it all together, and the actual cable routing. And all of that was done in about 2 hours versus an estimated 12 hours according to the end user. So essentially, in this case, an 85% reduction in time. And that's not counting the expenses that may be incurred due to additional site visits if, for example, the design wasn't done right in the first place. Now, alternatively, an RF expert or an engineer could have done that same work in less time. For example, by better estimating where to place the small cells, given the structural nature of the venue. But that would defeat the purpose of allowing the site work to be done by a non-expert. So in this particular case, we're talking about 10 hours that were saved. And what makes up those 10 hours? Well, it's a combination of the time saved in the survey aspect of sorting out the various documentation, such as notes and pictures. Now, that probably wouldn't change much if it was done by a technician or an engineer. But the other element is of that time saved is getting the small cell placement right in the first place, without needing to readjust it at a later time. And that clearly would not be the same if this was done by a non-expert or an RF engineer. So the bottom line to all this is that with the proper tool and proper training for field personnel or IT technicians, the survey and the design process can be done together quite rapidly, very affordably, and in a single site visit. So that pretty much concludes what I wanted to share with you today.
Thanks very much, Benoit. So again, I'd like to ask the audience our third and final question, which is really whether you believe that building owners or third parties could competently plan these in-building solutions. We talked about installation before, but do you think that with adequate training and standards, that's something that's feasible? And as you can see, the majority of people think that with adequate training and standards, it's probable. Benoit, do you have any comment on those poll results? Does that match what you hear in the field?
Yes, I think it does, and I think where there might be unlikely cases would be in much more complex venues that are structurally very complex, such as, for example, stadiums that would have inclined surfaces, where there you do require some expertise to do this right the first time around. But those results, yeah, certainly agree with what we're seeing, at least so far.
Great. Thanks, Benoit. So now we move on to our Q&A session. We have quite a few questions coming in, and we'll do our best to get through as many as we can. One of the first questions is for Alan, and that's, having said that there's a need for voice in the enterprise, why would this new 802.11ac Wi-Fi not meet the need for indoor voice service?
That's a great question. I think really the key drivers are around the enterprise architecture and how the enterprise has deployed AC, whether or not it's ubiquitous, is it everywhere, is it available? So that's one of the challenges. Certainly the throughput is there, but obviously you also have to have the quality of service. So a lot of it comes down to the design and how it's deployed. But I think in terms of comparing it with licensed radio, obviously there's a convenience factor with licensed radio. Often with voice over Wi-Fi, voice over IP, you have to have a client on the end user device. And that being said, our future's coming. Apple's made announcements with regards to clientless Wi-Fi access. So I think it's an interesting space. Watch it. There's going to be, I think, a lot of innovation there. So I don't know that in the future there'll be a terrible difference between the two.
Okay, and just a quick clarification from one viewer. You said that you're deploying 10,000 enterprise access points per day, and could you clarify that those are Wi-Fi or small cells or a combination of both?
Yes, those are enterprise class Wi-Fi access points.
Okay, thanks. And one for you, Benoit. How do you account for the macro interference? You talked about the in-building systems and how access points or small cells close to each other would be catered for, but how do you allow for external signals from outside?
Yes. So so that does need to be taken into account for sure, and the tool does that. So it accounts for interference that may result from the macro network. In fact, in different ways, it can be levels can be entered manually, or the phone or the tablet, which is used to run the mobile planner, can also take its own reading. Or also you can connect to an existing RF collection device and have a lot of that work done in the background, so to speak, to simplify the task as much as possible. And so when that is done, the propagation maps that are generated once the user has placed the access points, the small cells, then automatically that interference will be taken into consideration.
Thanks. Another one for you, Alan. I did ask you first about voice over Wi-Fi, but and in my section I did question whether it was 3G voice or potentially LTE voice. So when do you think VoLTE will replace 3G voice as the killer app?
Well, I think that's going to be driven by the end user device. So I think the market is moving quite quickly. So I don't know in terms of timing. In terms of voice over LTE, I think there's also some work being done around the standards. So I think I'll defer that question for the time being.
Yeah, I mean, from my point of view, I guess it's also dependent on the installed base of handsets supporting VoLTE. It's all very well for the network to provide the service, but it takes some time for the churn of new devices to catch up with that. So I think, from my point of view, I think even if it were launched this year, it would take 2 or 3 years before it will have sufficient critical mass that you could turn off or not use 3G. Again, another quick question and clarification from a viewer. Can we integrate both LTE and Wi-Fi and the existing 3G femtocells with the same access controller?
Is the same access point or our Wi-Fi controller?
Well, the question was access controller. I think that's the signaling gateway or controller on site.
So can the wireless LAN controller basically manage 3G and LTE small cell devices as well as Wi-Fi?
And Wi-Fi, yes. I think that's the question.
Yes. So certainly today the wireless LAN controller manages the 3G component of our clip-on, which attaches to the 36 and 3700, and it will be in our roadmap that will support an LTE clip-on in the future. And obviously today it does manage the Wi-Fi.
Right, thanks. Question for you, Benoit. of course, there's a difference between 3G and 4G. As you're doing your planning, particularly with these future multi-mode small cells, is there a radical difference between how you do this for 3G and 4G?
Well, not really, in the sense that when a small cell part is selected, whether it supports 3G or 4G, the process is the same. One difference might be a 4G will be typically much more data intensive, and therefore data throughput starts to become a lot more important. So that will become an important KPI to ensure is met during the design process. But the basic steps are essentially the same between the two.
Okay, and another one for you, Benoit. In step 2 of your 3-step design simplicity, does the propagation map created take account of the building material? So, if you've got building walls that are maybe thicker or less conducive than others.
So the way this works is that different density zones can be selected. So when site parameters are set in the first step, so you obtain the floor layout and then need to assign the physical characteristic of the building. So if it's a uniform type of density, there's 6 different density zones that are supported, ranging from a wide open space, as you would have in a garage or in a warehouse, to a very dense RF environment that you would typically have in hotel rooms or hospital, and then different zones in between. And then you can also assign different subzones within the building. So the idea is to try to keep this as simple as possible and not have to model every individual obstacle, because that will start to defeat the purpose of how simple and quick the tool can be used.
Mm-hmm.
So
right.
It does take it into account through those density zones that can be selected at the beginning of the process.
Okay, that's very helpful, a thorough answer. A question really about whether you need it. There must be some smaller enterprises that perhaps don't need a survey at all. Maybe if I ask Alan this one first, is there likely to be some enterprise deployments that don't need a survey, and if so, kind of how many access points would we be talking about?
Well, I think the end user experience should be self-evident, right? If there's poor in-building coverage or no coverage, right? Clearly, there's a demand and a requirement for it. When we look at sort of the coverage that 1 or 2 access points or small cells can provide, typically they can cover a good chunk of the marketplace based on our analysis, looking at the average size of these buildings and where we have a footprint today. So we think these buildings are a little less complex than vast warehouses and other large buildings with multiple floors. So we do think these branch offices, remote offices, are places where there are macro challenges in terms of connectivity, and we think that it's a ripe market for a simple and rapidly deployed solution.
And Benoit, would you have a view on that?
Well, so I certainly agree with what Alan said. I would add to this that no matter how small the venue also might be or simple, an important part of the process is the documentation aspect of it. So in a very simple venue, a survey typically would still be needed. It might be significantly simpler and quicker to do, but the documentation aspect is always going to be important, because there's always going to be a need at some point down the line to make some changes to it. So it's important to capture this in the early phases.
Okay, and if we just ask a similar question, but at the sort of larger end of the scale, is there a particular size you might feel is not appropriate to use your design tool or this approach? Where you need to call in more specialized planners?
Well, that's a very good question, and that may vary from case to case or different enterprises. But I would say that what probably will distinguish whether that approach is the right one or not is maybe not as much the size of the building as much as the complexity of the building structure. For example, if you talk about a stadium, so a stadium is quite large, but one of the complexities of the stadium is that it has inclined surfaces. And so the planning process needs to be more elaborate, and a more powerful desktop-based tool would be more appropriate. Or if you have a building that has a lot of differences in types of walls or materials or densities, then it may be more appropriate to individually model some of those key obstacles. So it's more about the complexity of the venue than the size of the venue per se.
In a simplistic view, if I've got a sort of standard tower block with office accommodation in there, that would be something that I could reasonably expect to use this approach with. But if it was more of a stadium or some unusual building, then that's where I'd need maybe to call in some extra expertise.
That's correct, yeah.
Yeah.
Or at least if you do, in some cases, if you do design on site, then the validation aspect of it would become more important.
As you showed, that could then be shared with a more experienced RF engineer, and they could spend more time on it as required. Okay.
Yeah, correct, yeah.
Okay, another question for you, Alan. Somebody's quite keen to spend money. What's the extra cost of installing small cells if that's done at the same time as one of these new 802.11ac enterprise deployments?
Well, we have a portfolio of choices, of course. We're Cisco with a large pool of options for customers. We have a standalone device, which lists around $500–600. That's typically deployed with service providers, so they may very well choose to position it in the marketplace on a monthly rate or however they choose to offer their service. I think what's unique, and I talked earlier about how regulation has kind of freed up things a little bit, we can actually sell the hardware directly to enterprise customers. So that would be a price point, and today the 5310 is listed at about $1,240, and then enterprises and channel partners can apply their discount to that. But that for all intents and purposes will not work until the operator enables it. And so we sell software to the operator who can then basically enable the small cell device at the enterprise. And we've got technology that helps facilitate the easy implementation of that. We've got a cloud-based technology that really helps deploy at scale. So roughly speaking, for enterprise and channel partners, the list price of the clip-on, the 5310, is about $1,200, and then the standalone is about $600. At list.
Okay, and presumably you would need an access controller or some other equipment in the network operator to connect it to, and some planning and SI services. So it starts at potentially a very low price, but it's significantly cheaper than the hundreds of thousands of dollars that we've heard in the past for something significant like a DAS system.
Absolutely, and that's the choice that we'd like to see, operators offer, right? Is that as a channel partner is deploying a Wi-Fi solution, that they could also offer an in-building small cell service, so that while they're deploying Wi-Fi, at the same time they can deploy the small cell device and lower the enterprise customer's cost.
So in your experience, you've talked to a lot of enterprise customers as they're deploying the Wi-Fi. Are you hearing a lot of demand for small cell deployment in this mode? And if so, kind of what's holding it back?
Yeah, we are. Our phones are ringing off the hook. Obviously, the product's been announced. It's been available in Europe since last November. And what's holding it back is really the work that we're doing right now with the operators in terms of standardization, productization, and making sure this is going to be a great service experience for our customers. So that's really where we're at right now. We're working in concert with operators to announce service availability, and that's here in Europe. It's on a per country basis, you know, this is very early technology. I think that we have to simplify it in terms of, you know, the network assessment. I think there's a lot of questions that enterprise customers have around deployment and how it's going to integrate with their network and how they're going to basically provide backhaul and quality of service. So, you know, while, you know, we see a very large amount of interest, a lot of demand, I think that enterprise customers, you know, have realistic expectations around the technology. I think many of the customers that we're talking to, well, they have business needs, and it's not something that they're going to deploy in massive scale. I think the conversations we're having is they want to trial this, they want to test it in cafeterias, in conference rooms, in, you know, executive row, where they've got clear dark spots, and then sort of start to consider an enterprise-wide architecture and really how they can kind of begin to more broadly deploy it. So those are the conversations we're having with pilot customers today.
Yeah, so there's clearly a lot of demand, and just another viewer on the webinar is asking, could you restate the Cisco model number of this small cell device so that he can look up the information on the web and maybe place some orders?
Well, okay, yes. The product is called the USC 5310, and it is our 3GPP product. It's basically band limited, you know, obviously for specific operators in specific countries, so you need to validate that indeed it is supported for your country. But at the same time, the product does not work until an operator has productized it, standardized on it, and is making a market offer. And so, for all intents and purposes, you know, it might as well be a paperweight until that operator indeed agrees to turn it on. Right. And that's the work that we're doing today.
Yeah, yeah. So when you say standardized, you don't mean like a 3GPP standards release. No. You mean the process is standardized and agreed, and yes, the parameters. Okay, we've had a few questions for you. If I could switch back to Benoit, you may want to rephrase this question. We've got a number of buyers on the line. They're keen to know, given the $1,200 cost for the hardware from Alan, what would your software cost be to design this small cell?
Well, it's the software is significantly cheaper than the desktop tool, which is used for more complex venues. So it actually varies depending on the level of sophistication that may be required. And I won't give an exact figure just because we're about to launch a new version of it. In fact, just in a couple of weeks this month. So, but we're talking in order of magnitude less than what's currently available with iBwave desktop design tool. So we're talking something in the order of a few $1,000s. And obviously with that you can plan many sites, so this is amortized over a larger number of sites.
Okay. Slightly unrelated question. When you're doing this planning, you talked a lot about coverage, and I think some of the viewers got the clear message you'd have good coverage. What do you do to ensure you've got good capacity?
Yeah, that's right. So there's in fact there are three different parameters that are important. So one is coverage certainly, and the other one is data throughput, and capacity. Capacity is a third one. So capacity will be dependent on the capacity which is supported by the small cell. So this will be modeled as part of the small cell part that comes into the parts database. And there's another limiting factor as well, which is the capacity of the backhaul that comes into the building in the first place, just to ensure that this will be sufficient.
Great. Okay. I think we've just come to the top of the hour now, and I have hit you both with quite a lot of questions. I'm afraid we haven't had time to answer all of the questions submitted, but we did have a lot of engagement from those online. So just as a wrap up, if you want more information about small cells, and there's plenty of insights into how these small cell works, what the vendors are, what the architecture is, and some of the solutions available, then do visit our website, ThinkSmallCell.com. You can also find out more about Cisco's solutions or iBwave's products on those links. And you can access our white paper through the website or through the link shown on your screen now. And our next webinar is about 3 weeks' time. We'll be looking at these various enterprise wireless or cellular solutions. There's quite a number of different architectures now for in-building enterprise, and we'll be breaking those down, looking at those from an architectural point of view, everything from small cells through distributed radio systems and distributed antenna systems. So do sign up for that webinar if you're interested. Again, the slides, the recording of this will be sent round by email. And just before we close, I just wonder whether I could ask our speakers just for a very short wrap-up, closing thoughts. Alan.
Yeah, thanks very much, David. Very much appreciate the opportunity, and I just want to thank everybody for the valuable time today. I know that we have a lot of different audiences out there from around the world. I think to our enterprise managers for small and large businesses, I'd say that this is an early market, that operators really have the first word in terms of service availability. So we do have to wait until they're ready to deploy. And I think to our operator customers, we recognize that there is always risk in new markets, but without a doubt, we see a huge opportunity, and we think that it can be reached at a very low cost. So we look forward to making it work with both of our customers. Thank you.
Thanks very much, Alan. Benoit, do you have any closing thoughts?
Just to thank you for the opportunity. There were a lot of interesting questions. Wish we had a little bit more time. But certainly from what we can see at this point is that there is a lot of interest in this approach of doing as much as possible into a single site visit. It's addressing a lot of pains today, and one of the biggest challenges with these small cell deployments is going to be the scale of deployment, hence the need for not only having something which is simple but to use and quick to use, but not requiring a lot of expertise in the field, because this is something that is just not going to scale. So a lot of trials that we're having, a lot of enterprises and in fact operators we're talking to are also coming to that realization as the volume of these deployments is gradually starting to increase now. So.
Thanks, Benoit. I'm sure that this is going to be quite an exciting market sector to watch over the next year or two, because there's clearly demand, and I think as we've demonstrated on the event itself, there are connectivity problems in buildings around the world that need to be addressed. So with that, I'd like to thank both our speakers. I'd like to thank all of the audience for joining us, and look forward to our next webinar on the 24th. Thanks very much.